Okay, welcome, Josh and Jacob and Sylvia and Aubrey. Thanks for coming, and welcome for those who are watching this as a YouTube archive video. This is the week 6 webinar, and we will be talking about chapter 8, which is confidence intervals. This is kind of a big week in that we're really changing what we're doing. So you may or may not have noticed, but everything we've done just about since the beginning of the class was a bunch of stuff to be able to understand probability or understand the normal distribution, theorem, that kind of stuff. But from today on, now it's about using statistics. So it's very, very easy for me to just go online, look at the news, and find what we're doing. And I'll be able to do that pretty much every week for the rest of the quarter, is because this stuff is used. Sometimes it's in regular news, sometimes it's in journal articles where they'll be doing some research, and not about statistics, about psychology or about sports or whatever it might be. And in that research, they use what we're using. Today's stuff is used all the time, not just in fancy journal articles, but in just everyday things. But the details are usually at the bottom of the article because most people don't want to see statistics. So what I hope is by the end of this week, you're going to be able to look at these articles and have a much better sense of whether they've done their work right and really understand what they're talking about when kind of at the bottom of the article when they go over the details. I wanted to start out before I get into the content of confidence intervals to remind you and talk about a couple things. First, November, I believe it is November 8th, I think it is. Let me triple check. Yeah, November 8th, you must have your midterm taken. And that must be by an official proctor, not an online proctor, but at a proctor center. If you're in Tahoe, come to our library. That's where the proctoring is done. They have a room right for it. It's free. Free is always good. It's best if, and you should call them ahead of time or go there ahead of time, a day ahead of time, to make sure they have space for you. They almost certainly will, but you should definitely contact them to reserve a space so that they can make that proctoring, because there's only one room, and if 50 people all wanted at once, they'd be in trouble. So make sure that you do reserve a space. If you don't live in Tahoe and you don't want to come to our beautiful town, which it really is beautiful if you haven't been to Tahoe, but if you can't get here, then you can take it at any proctoring center that will do it for you. Typical places are the college. If you happen to be a student at a college, most of that college will usually proctor your test for you. They usually have a testing center and just go. You need to let me know the information, because if I don't know, then they won't have your test because I have to send them the test. I usually check the website, make sure they're official, make sure they're real, and that works. If you can't get to a college, or if you're not a student at a college and they won't do it for you, public libraries will often offer proctoring services. And so will the Sylvan Learning Center. They charge a little bit. That's the only problem with them, that they're a bit expensive. But you only take 2 tests. One reason I only do 2 tests is because that reason. My regular face-to-face class has 3 tests. That's one big difference between these two, is that you have fewer tests. So yeah, the midterm and the final. Other places that you can go besides the Sylvan Learning Center, if you're in the military, your commanding officer is fine. As long as they're official, we can make that happen. Like I said, I can be flexible. It needs to be something official, though. That's what I asked for. If you happen to be at a college and the proctor center won't do it, but maybe they'll do it at your counseling services. That's fine too. I just want to make sure it's official. Okay. Any questions at all? Any questions at all about the the proctoring. Okay, when you have identified it, email it to me. That's not when you post on any forum, not when you email it to me, because it's really none of anyone else's business where you're taking the proctor. It doesn't help others to hear what you're doing. Let me know the date and the contact information so I know where to send your test to. If I don't know, you have no test, and then it doesn't work. Don't wait. If you can do it a week before you're going to take it, that's best, because then I have time to get it to them, and if anything happens, they can fix that issue. So a week is the safest. I'll remind you many times before now and then, but I want to remind you. The second bit, and I'm only going to kind of start on this. This isn't a whole webinar on the project, but project 2. So a couple things is you don't have to use the same partners. I've noticed that the project discussion forum has already gotten busy, and people looking for partners. They want to switch, or they didn't have one in the first place, which is a really bad idea. And now they know it's a bad idea. Or they only had 2, and now they want a 3rd. That's happened too. But make sure you have your partner situation dealt with right away, because the sooner the better. You have lots of time for this project, but I was reading through your last week's discussion post assignment, and a lot of you said that you wish you had started earlier. So I figure I would address that and tell you how to start earlier. The first thing, of course, is find partners. Okay, decide who you're going to work with. Again, you don't have to work with the same people, but you can't work alone. You work alone, there's a very severe penalty for that. The 15%, which is really bad. And that's from what you earn. So if you got a B, now you got a D. You see that? Makes a big difference. So make sure you have a partner. Next, what you're going to do in this project, again, we don't understand all of it yet because we haven't had it, but we're going to be talking about confidence intervals today. And what part of the project is to construct a confidence interval. So similar, you're going to have to do some kind of research. This is not about the sampling technique. You can use convenience sampling. You just have to admit to it, and that's fine. Just talk about the sampling technique, but you don't have to spend a lot of time on the sampling. You could even collect data that isn't a survey. In other words, you can go and measure, I don't know, the height of a bunch of corn stalks in your neighborhood, if that's what you're doing. Okay? The point is, it doesn't have to be an answer from a person, but it needs to be data. And what you're going to be doing is you're going to be doing a comparison study. So you're either going to compare the answers from 2 different groups, so like men versus women, or you're going to be comparing the answers to 2 questions. So that would be like finding out whether people spend more time on the weekends online than they do during the week per day. That would be something you can do, where you're asking a person 2 questions. How much time did you spend online on Saturday versus how much time did you spend online on maybe Wednesday? And you're comparing that. The answers must be what I call subtractable. So in other words, hours to hours. You can't ask someone, for example, how much do they weigh and how tall are they? Because you can't take 5'5" minus 185 pounds and get something. Is that clear? Okay. I'm not going to go over all the details because we don't have the math yet, but you can start thinking about your project now. Are there any questions before I move on to confidence intervals? Any questions? Jacob, Josh, Amanda, Sylvia, or Aubrey? Any questions? Okay. Okay. Just a note, pretty soon we're going to start having 2 webinars, because I'm going to do one to review for the midterm, for example, and then one for the chapter that we're working on. And then I think the following week I'll do one to talk about the project, a full webinar, not just 3 minutes, and then one on the chapter we're working on. So this week we're just focusing on chapter 7, and it's a little too early to deal with the midterm. So any questions before I move on? Okay, as I mentioned, my promise was that all of this stuff that we're about to talk about relates to the real world, and it's really easy to find online articles without a problem. So what I'm going to do is I'm going to share my desktop or share my screen. See if I can find it. I got to find the right one. Sorry about that. There's a lot on here. No, it's not that one. It's that one. And let me also open the chat so I have it. Okay, so hopefully you're all reading. This is an article. I'd like to go to the source. You could find this on CNN or Fox or whatever your news station is, LA Times or whatever you look at. I'd like to go to the source where they get their information. What they do is they tend to pay or hire researchers to do the work for them, and then they write a fancy article. And so this is Gallup, which is a surveying company for news sites, basically, and other things. And this is an article, gun control remains an important factor for US voters. So I don't know if any of you care about gun control, but whether you do or not, you have to listen to it, because that's what I thought it was a nice one. It's kind of big in the news, especially after the horrible tragedy that happened in Vegas. A lot of people are thinking about it now. So I think everyone agrees that was terrible. I can't imagine anyone not thinking it was like really horrible. But we can talk about gun control. I'm not going to tell you how you should vote on gun control, but I will tell you you need to understand articles like this and to be able to understand the statistics. So that's the plan. So story highlights. 24% of voters say a candidate must share their views on gun control. Okay, so the question is, does Gallup know this? That exactly 24% of all voters think that the candidate must share their views? What do you think, yes or no? Put it in your chat box. Do you think Gallup really knows that 24%? Okay, and why don't they know? So you're right, they don't know. And why don't they know? Why don't I know for sure that they don't know, and you probably don't know. You know for sure too, is my guess. Any guess? Okay. Yeah, so all people. I know for sure because they didn't ask me. So they don't know what I think because they didn't ask. Okay, but they say 24%. So the next question I have is, they don't know it's exactly 24%. So the question is, do you think it could be 80%? What do you think? Do you think 80%? Okay, so the answer is probably not 80%. That'd be really, really unlikely, and we'll see that in a little bit. But what do you think about maybe 25% instead of 24%? Okay, and the hope is, you see, that's reasonable. That would be reasonable to say they might be off by 1%. So what we're going to be looking at this week is to say, well, now that they've done a study and you have, or they have, done the statistics, calculated it out, and they cite 1%, we want to be able to look at, well, what's a reasonable range of percents that it could be, given the fact they did this study. And we have spent some time already on this, realizing that when you do a study for a large sample size, and we'll see in a minute they did a large sample size, that the sampling distribution is approximately normal. I hope you all know that. That's the central limit theorem. Is that okay? So the sampling distribution is approximately normal, and you can calculate the standard deviation using the central limit theorem. This is a yes or no question, and it's a yes or no question because it's, do you think that the candidates must share their views on gun control? Right? I think they should, or I don't think they need to. It's not important. Okay, that's definitely a yes or no. I'm actually kind of personally surprised only 24% think that they should share their views. My feeling is candidates should just share their views, but that's nothing to do with statistics. Maybe you don't agree. Maybe you think that that should be in their private life, so it's okay. But 24% is what they got. So Then the question is, now we have a standard deviation, we know it's a normal curve. Now we can talk about how likely it is to be in an interval. Okay, so now I'm going to scroll down to the bottom. I don't want to read the whole article, that's not the point of this. And I want to look at the survey methods. So results for this Gallup poll are based on telephone interviews conducted August 5th through 11th, pretty recently, 2017. Okay, trying to remember when the massacre was, but whether it was before or after, but I'm not too, that's not what this is about. With a random sample of 890 adults. So first thing, is that a big enough sample to be used in normal distribution, to use the central limit theorem? Okay, now here's what I don't want you to say. Don't say yes because it's more than 30. What's wrong with that? Maybe some of you are about to say that, but that's not the answer. It's yes, but not because it's more than 30. Anyone see why? Not sure? It's only for a sample deviation, not quite sample deviation, it's only for a quantitative survey question. It's not about representing the population. If they did their job, then they represented the population. But for the central limit theorem to apply, it's only when the survey question is quantitative, has a number answer. This is a yes or no answer. Now, if you remember for a yes or no answer, do you remember what you need? Any of you remember that? I don't see you all typing, but not 10 from each group, more than 5 yeses and more than 5 nos. And I'm not going to do the arithmetic because I think it's just obvious, hopefully, to y'all. 24% of 890 is bigger than 5. Right? 24% of 100 is 24. So 24% of 890 is much bigger than 5. And that's the number of yeses. 24%, if you take the complement of that, okay, that's going to be, what, 76%. 76% of 890 is much bigger than 5. So, yes, we have a big enough sample. Any questions on that reasoning? So I want you to be very careful. The very first thing you should do in anything we do for the rest of this entire quarter is say, are we in the realm of the yes or no question? Or are we in the realm of the quantitative question, the number answer question? If we're in number answer, you go over 30 is what you want. If you're in yes or no, you need more than 5 yeses and more than 5 nos. So again, if you have any questions, let me know because I'd be happy to clarify that. That's kind of the point of these webinars. Okay, so that's old stuff still, right? Because central limit theorem was last week. Okay, they looked at people living in all 50 US states, District of Columbia, Washington, D.C., who are registered to vote. Okay, so they didn't give you all the information to tell you whether this is a really good one, but they do tell you 70% cell phone, 30% landline, and then minimum quotas by time zone within region. So that's stratified sampling. So I don't know if you remember from chapter 1, but when you have quotas by time zone or quotas by anything, that's stratified. Okay, so again, that's any excuse to review is a good excuse. But then comes the new part. So here comes the new part. For results based on the total sample of registered voters, the margin of sampling error is plus or minus 4 percentage points at the 95% confidence level. Okay, so that's going to be, that's what today is all about and this week, is the margin of sampling error, the margin of error, sometimes they call it, and confidence level and confidence interval we're going to have. All reported margins of sampling error include computed design effects for weighting. Don't worry about that. That last sentence is advanced statistics that we don't do in this class. So just brush it off. Don't worry about it. If you want to learn about it, take more stats when we're done with this class. But the first part you do need to understand by the end of the week. So the first thing, let's go to the 4 percentage points. Okay, so remember, if we looked at, we had 24% of voters say candidate must share their views on gun control. So now we say the margin of error is 4 percentage points. So that means from 24%, we're going to go up and down 4 percentage points and say that it's likely 95% is the confidence interval. That tells you about the likelihood that somewhere between 20 and 28%, because if you go 24%, you go down 4%, that's 20%. If you take 24% and you go up 4%, that's 28%. So somewhere between 20 and 28% of all voters in all of America, all registered voters, think that the candidate must share their views on gun control. So notice that they only asked 860 or so people. I think that's what it was. Yeah, 890 people. They only asked 890 people. But now with statistics, we understand that with that sample, we can say with 95% confidence that they're only off by at most 4%. So the 4% is called the margin of error, and the 20 to 28%, that range, is called the 95% confidence interval. So just a note, do you remember from the empirical rule what 95% of the data under a normal curve contains? Remember how many standard deviations on each side? Let's see if you can put in your chat box. Do you remember that? There was a rule about 95. So the nice thing about this is it brings everything together. Not 3. 3 was 99.7. 0.025 is how much area there is on either side. But the z-score, yeah, 2. So within 2 standard deviations is between 20% and 28%. So do you remember that happening? That's what we've been doing the last few weeks. And the whole point of all that is to really understand what it means to say that the margin of error is 4% at 95% confidence level. So any questions? So this is a big deal. Any questions at all? Okay, so when they do research, this is how you do research. You have to make sure your confidence, you have to make sure your sample size is large enough so that you end up with a small margin of error. So Josh, you have a really good question. Do we say that it's 95% right? You kind of have the right idea, but let me be a little more precise, which I'll be in an example or two later. What we can say is that Gallup, hopefully you know, Gallup is in the business of conducting surveys. And they're in the business of coming up with confidence intervals. So what you can say is that 95% of the time that they end up with a confidence interval, it's actually going to contain that true mean, the true population mean, which we don't know. And 5%, I like to think of it as they end up with a confidence interval that's a loser. They missed it. You see that? So of all the times they've been doing it, and they've been doing this for decades and decades, longer than I've been alive, actually. Gallup is a very old company. 95% of the time, they get it right. And what you may not know is that that was decided to use 95% by the New York Times in the 1930s. So they made that decision that they were okay with 95%. And if you know your history, the New York Times was the ruler of all news in the 1930s. So they said it, so that's what everyone went with, the 95%. So that's why we use it. Sometimes, for news, you use 95%, but sometimes you might want to be more than 95% confident. So for example, if you're doing a medical study And if you're wrong, then you kill the person. And if you're right, then you've helped their acne a little bit. They have fewer pimples. Do you think you're okay with 95%? Do you think you're okay if there's a 5% chance that you kill the person so that you can make sure that they have a little less acne? Probably not. Okay, I hope you're not okay with that. So in that case, you're going to use like a 99.9% confidence interval. You want to really, really be confident. Okay? So on the other hand, if you really don't care at all that much, or if you don't have enough time for a big sample size, then you might go with a 90%, a little lower percent. Okay? News, you always do 95%. For research in social sciences, always 95%. But for sometimes you go over or under, depending on what you're doing. The other thing is that if you go to a higher percent, you might want to say, well, don't we want a 99%? Wouldn't that be better? Except if you do that, you have a bigger margin of error. That means it's wider. So if, for example, if you wanted to find out the average female height in America, and you went with a 99.99% confidence level, then you may end up saying that, well, the average female height is between 2 feet and 20 feet. And how much does that help you? Right? So if you end up being able to conclude that women are somewhere between 2 and 20 feet tall on average for adult women, then you've actually contributed nothing. Do you agree? But you're 99.99% certain that's true. Do you see that? But it doesn't help. So you got to decide where you want that confidence interval. If you make it lower, then you can have a smaller margin of error. Then you might be able to say that women are between 5'4" and 5'4.3. You see? And you have really good numbers, but you might be 10% chance of being wrong. You see how that works? So that's the issue with the confidence level, is there's a trade-off. Is that if you make the confidence interval higher, your margin of error gets wider and you have information that's not very helpful. If you make the confidence interval lower, then you have more helpful information, except you have a higher chance of being wrong. So it's a trade-off. If you want both, if you want a high level of confidence and a small margin of error, what's the only thing you can do? There's only one way of doing that. Anyone know? There's only one way of getting a very good confidence with a very small margin of error. And the key is it's in the central limit theorem. Any thoughts? Another hint is it's a lot of work. Don't see you all typing? Okay, if you, population mean, you can't change that. Like if you wanted to do average women height, you can't change the population women's height, right? There's no way you're gonna be able to do that. And you don't want to do that anyway. You're guessing at the population mean, you're not trying to change it. Does that make sense, Josh? So the only thing you can do is survey more people. Because remember that the central limit theorem says that the standard error is sigma over root n. So if you have a bigger n, you have a smaller sigma over root n. And that makes the margin of error thinner, narrower. So the only thing you can do is make that sample size bigger. But it's a lot of work. You know, if you want to do a survey of 5,000 people, that would be horrible, right? I asked you to do 31 and that was a lot of work. Remember that? Imagine if Project 2 asked you to do 5,000 people, right? You'd probably all be dropping the class right now. So that's the problem with trying to do a very big sample size, is that it's a huge amount of work. And for Gallup, it's a lot of money. So they did 890 people, which is actually a little lower than they usually do. They usually do a little over 1,000. And they're okay living with a 4% plus or minus 4% for margin of error. Any questions at all on this idea? I wanted to get through the ideas. Okay, I want to check the work. It's always fun. And I have not checked it yet. Sometimes I check it and they're right and sometimes they're wrong. So let's check the work and see what happens. All right. And by the way, in your discussion post assignment, you're supposed to do an article like this, post one, and then reply to someone else by checking the work and evaluating it, and then coming up with conclusions. So that's what you're supposed to do. So I want to show you how to check the work. So first thing, I write some things down. We have 890, and we had 24% said yes, if you remember, and we wanted a 95% confidence interval. So now I want to go to my calculator, because to check the work, hopefully you've got that by now, is you need the calculator to check anybody's work. So let me do a share in the calculator. And let's clear out. So here's what you do. If you have your calculator, follow along, because my calculator might be a little different than yours. This is a TI 84 Plus Silver Edition. So whatever yours is might be different. And what I'm going to do is I'm going to go to Stat. Then I'm going to go to Tests. Okay, and then I'm going to go down pretty far, actually. To one prop Z int. One meant that there was one sample, one survey question. Prop means that it's a proportion, yes or no question. Z means that we have a large enough sample to do a normal distribution. And int stands for confidence interval. So let's hit enter. Now it's going to ask us for some things. So first thing I want to, I'm going to do this aside. You're not seeing it, but just trust me. 24% of 890. So 890 times 24. Actually, I think I can put it in here. Let's do it. So 0.24. So 890 times 0.24. Let's hit enter. Okay, now the calculator will not be okay with 213.6 because it makes no sense. It's not possible that 213.6 people said yes. Is that clear? So what I need to do is I need to round. And I'm going to round to the nearest whole number, so 214. That's something you're going to need to do if you're given a percent. 890 was the N. C level stands for confidence level. Nothing to do with, the fact that Tahoe is, over 6,000 feet in sea level, different sea level. And then calculate and hit enter. Okay, doesn't give you much because you don't need much. So notice that the one prop Z int, this is a confidence interval, goes from about 0.21 to 0.27. Any questions on that? So actually, according to our calculations, the margin of error is 3%. Because if you start at 24%, you go down 3% to get 21, or you go up 3% to get to 27. Okay? So the margin of error is actually a little less than they quoted. Like I said, Gallup often does that. They do a little extra conservative estimate, basically, just in case something went wrong. But technically, the margin of error should be plus or minus 3%, not 4%. Any questions on that? Any questions? Okay, so this is an example, and what I like about it is this is real. This is a current event, this is an article. I didn't pull it from some statistics page. Okay, you can find this on any news, all the main news article stations too, is they'll talk about gun control and surveys and stuff like that. And now we understand how to interpret these and to see when they say 24%, well, how far off are they? And we could say that we're 95% confident that between 21% and 27% of all Americans think that our representatives should tell us how they feel about gun control. Okay, which to me is very surprising. I would have guessed much higher, but this is what we got. Any questions at all on this example? Okay, so by the way, the 95% again means that if you do the study many times, 95% of the time, it's going to have the true population true population proportion of Americans who think that politicians should say how they feel about gun control. All right, let me reshare. And now I'm going to go to, okay, now we're going to do a problem. So let me go and copy one in. So this only applies to qualitative surveys, the yes or no surveys. So the answer is, it's funny, yes and no. So let me paste, and then you'll understand. All right, so here's the answer to the question. It's funny, I was about to do it. So you're interested in estimating the proportion. Oh, sorry, that's not what I want. Let me not do this one, because we just did a proportion one, and I don't want to do another one, because we only have so much time. Let me do this one. Okay, so you're interested in estimating the mean amount of time that LTCC students, Lake Tahoe Community College students, spend on campus on days that they do go to campus. Okay, so now we're talking face-to-face students. Based on prior knowledge, you know the standard deviation for all students is 1.3 hours. Okay, and also know the distribution is normal. The results of the survey asking randomly selected students are shown below. Determine a 90% confidence interval. So Josh, here's the answer to your question. This is I hope it's very clear to you. This is not a yes/no question, because those are the answers. And the first person says 2.5, not yes or no. Do you see that? Can we do a confidence interval? Absolutely. Okay. So that's the first thing, is let's get a confidence interval. So to get a confidence interval, here's our data. I'm going to go back to my calculator. And I apologize if you can't see the data anymore, so you're just going to have to trust me. Let's clear it out. Now I'm going to go to Stat. Oops, I'm going to go to Edit. And I'm going to put my data into L1. Okay, so the first number was 2.5. And then 3, then 4, then 2. Then 3.4. And then 5, 7, 9, 1. And then 14, then 11. Then 4, 5. Then 6.5. And then 8.5. Okay, so you put your data in the calculator. Then we go ahead, and I'm going to go to Stat. I'm going to go to Tests. Now, because I know the population standard deviation that was given in the question, it was 1.3 hours, I can use what's called a Z interval. If you don't know the standard deviation, we'd use a T interval. And I should have time to do one of those too, I hope. I'm going to hit Enter. I have data, so I'll go to Data. If I had statistics, like if I was told the mean and told the standard deviation, I'd go to Stats. Okay, the sigma was 1.3. It's interesting. That's from a different question, and it was still 1.3. And the list was L1. So second 1 gives me L1. I'm going to clear out this frequency is what I want to do. Uh-oh. No, I guess you do have to at 1 with this calculator. Confidence interval, we want a 90%, so I'm going to go 0.9. All right. Let me know if you're ready. If you're not ready for me to hit calculate, put something in the chat box or talk. As soon as I hit calculate, you can't see the stuff anymore. Okay, calculate. It's very easy. And we get about 5.2 to 6.3. Let's write that down. Any questions on what I did in my calculator? Okay, so I need to go to a new share, and I want to get back to Paint. So first thing, my confidence interval. Was 5.2 to 6.3. That's what the calculator gave me. Any questions on that? By the way, the margin of error is going to be half of that length. Because remember that the mean is right in the middle. So if you take 6.3 minus 5.2, you get 1.1. And half of that is 0.55. So the margin of error will be plus or minus 0.55. I didn't ask for it, but I figured I should tell you. Okay, so next, you use a complete sentence to interpret the interval. So we can say that with 90% confidence, between 5.2, actually, sorry, not between, but the population mean amount of time that LTCC students spend on campus on days they do go to campus is between 5.2 and 6.3 hours. Any questions at all? Any questions at all on interpreting, looking at the confidence interval? Okay, so part C is use a complete sentence to interpret the confidence level. Okay, so what we can say on this one, this is the kind of like if you're in the business of confidence intervals. Okay, so if many samples of size, I think there were 15, students are taken, each will produce its own confidence interval. Okay, so the idea is that if you went and asked another 15 students, you get different numbers, and you get a different confidence interval because you have different numbers. And then if you went and asked another 15 students, you get a different confidence interval. Okay, they're not going to be 5.2 to 6.3 each. They're all going to be different. Some are going to contain the population mean, and some will not. And in fact, 90% will. Okay, then 90% of these confidence intervals will contain the true population mean number of hours that students spend on campus when they do go to campus. Any questions? Any questions on interpreting the confidence level? So notice that the first sentence or two, this first paragraph, is interpreting the confidence interval, and the second is interpreting the confidence level. Don't get those confused. I will always ask you to interpret the confidence interval. Okay? Confidence level, sometimes you'll get asked. Part D. If the distribution had not been normal, would the confidence interval still have been valid? Explain. So this is about sample size. What do you think? Oh, discuss margin of error again, Josh? Sorry, I just noticed it. So we have 5.2 to 6.3. That's a length of 1.1. So right in the middle of that is going to be the sample mean. The distance from the sample mean to the edge is the margin of error. So that means half that full distance is going to be the margin of error. So half of 1.1 is 0.55. Okay. Okay, so last thing is, had the distribution not been normal, would the confidence interval still have been valid? In other words, was our sample size large enough? What do you think? What do you think? Was it large enough? The sample size was 15, by the way, as we saw if many samples of size 15. Okay, the answer is 15 is smaller than 31. It's not bigger than 30. So since 15 is less than 31, the normality assumption was necessary. What just happened? There we go. Assumption was necessary. So if you didn't know the population was normal, then this confidence interval would be nonsense. Just wrong. Does that make sense? So it would just be wrong. You couldn't do it. So here's the problem. If you have a small sample size, you probably don't know the population's normal, because who knows about the population? So if you have a small sample size, don't do statistics. Okay? The only reason I give examples of small sample size is just because it takes less time to put in the calculator, and I could show you what I'm doing. Otherwise, we spend too much time typing. But in the real world, don't do small sample sizes, ever. You should always get over 30. And if you have a yes-no question, you want to make sure that the number of yeses and the number of no's are bigger than 5. And typically with yes-no, you want to be in the range of 1,000 or so. You'll notice Gallup did a lot of people. And with quantitative, you don't need quite as many, but you need more than 30 for sure. Any questions on this example? Okay, let me do another example. Let me erase this one first, sorry. Okay, here's the next one. Sorry if it still says number 1. That's the copy-paste issue. You want to estimate the average amount of chocolate Americans eat each year. Sounds like a good thing. Probably can't ask every American. It would take too long, right? You survey 64 randomly selected Americans and found they averaged 12 pounds of chocolate consumed per year. Their standard deviation was 2.8 pounds. And let's assume the distribution of chocolate consumption is normal. So basically, do everything we just did. Okay, except confidence interval is good enough. All right, so let me write some things down. So 64, we have is n, or the sample size. The mean, x bar, not mu, but x bar, is 12. And the standard deviation, it's the standard deviation of them, not the entire country. That's S equals 2.8. So now I can share my calculator again. Okay, so here's the calculator. I'm going to clear out what I had. I'm going to go to stat. I don't have data to put in this time. So I'm going to go right to tests. Okay, in this case, we don't know the standard deviation of the population. We only know the standard deviation of the sample. And if you remember, the central limit theorem tells you that sigma sub x bar is sigma over root n, not S over root n. So what we're going to do is we're going to use S to approximate sigma. And the problem with that is it adds extra error. Because we don't know sigma, so we have to have a little extra error because we're going to use S, which isn't exactly sigma. It's a best guess, though. And it turns out that because of that, you do an adjustment on the normal distribution. This is something that was figured out a long time ago. And it was funny, the guy was drinking beer. Sounds weird. But he was a statistician who happened to work for a beer company doing data analysis for the beer company. And he realized that if you didn't do this adjustment, then he didn't have 95% of the confidence intervals end up with the true population mean. He was off. He had fewer than 95%. So he came up with the math, which is really brutal math. You don't have to do the math. All you have to do is remember the letter T. And he worked for a beer company, was also a professor, and he named it after his students. So it's officially called the student T distribution, named after this guy's students. Fisher, I think his name was. Okay, so what we're going to do now is I'm going to go to T interval, not Z interval. T means that we don't know the population standard deviation, so we have to use this T distribution, which is, again, comes from the normal distribution with a little error extra added to it. In this case, I don't have data, I have statistics. So I'm going to enter on statistics, and now it's going to ask us things. So x bar in this case was 12. That was given in the problem. Sx, that was the standard deviation of the sample. That was 2.8. By the way, had we had data, we do the same thing we just did before with data, and we go to T interval. N in this case was 64. And the C level, let's do 0.95, I think. Yep, 95%. And then go to calculate. Any questions before I click on it? Okay. So there it is. Very easy. There's not much information. It just tells you what you need. About 11.3 to 12.7. Any questions on that? Okay, let me go back to the question again. Okay, so the first thing, the confidence interval, very simple. It's 11.3 to 12.7. Close the bracket. Okay, so now what we can say, we want to interpret it. Notice it's interpret the interval, not the level, but the interval. So that means that with 95% confidence, the population mean amount of chocolate that Americans eat each year is between 11.3 and 12.7 pounds. Any questions on this? Any questions? Okay, so the next question, if the distribution had not been normal, would this confidence interval still have been valid? We found out in the last one it was a no. How about in this one? Put in your chat box, yes or no, would it have been valid? Okay, yeah, so now we have a sample size of 64. So since n is equal to 64, which is certainly greater than 30, plenty greater than 30, the central limit theorem tells us that the sampling distribution is normal. Distribution is approximately normal. So the assumption is unnecessary. That doesn't look right. One in? Sure. Don't laugh at my spelling. Any questions at all? Any questions at all on this example? Any questions? Okay, I have one more example question to show you guys. Let's do that. Got to kill a little more. Okay, so here's the question. Suppose you want to construct a 90% confidence interval for the mean number of spam emails that come in daily per account, and want a margin of error of no more than 0.8 spam emails. If you know that the standard deviation of spam emails is 14, how many email accounts must you monitor? Any questions on the question? So notice this is very different. This is not asking for a confidence interval. This is deciding when you're looking at the sample, when you're looking at the study, how big a sample size do you need? Now, we definitely want it to be over 30, but maybe we need to be a lot over 30 because we want to make sure our margin of error is small. And remember, if your margin of error is small, your sample size is bigger. So how big a sample size do we need so that we get this margin of error? Any questions on this? So what we're going to need for this is a formula. And the formula, the first thing, we're looking for sample size. Sample size is always called n. So n is equal to z times sigma over E squared. Any questions so far? Okay, I'm not going to derive this formula. We don't have the time. There are also formulas for proportion, and you're responsible for watching these the chapter video and reading the chapter and find those proportions also. This is the formula for when it is a quantitative survey question. So the first thing, we got some numbers. Okay, we want the margin of error to be no more than 0.8. That's E. So I can type that in. So E is equal to 0.8. Okay, the plus or minus is not important because you're squaring it. Negatives get killed when you square them. Sigma, I guess I got to write that in pen. Is also given. That is equal to 14. Okay, Z we have to do some work on. And I'm going to draw the picture, and you better be used to this picture. Whenever I say picture, it's always that one. And what we have here is we want a 90% confidence interval. So that tells you that area right there is 0.9. So if that area is 0.9, what's this area here? See if you can put in your chat box what that area is. Point something. Yeah, 0.05. All right. What we're interested in, what we need to have from the formula that I just wrote down is Z, and that's Z. Z in the standard normal. Okay, so if you give it an area under a normal curve and you want to find the value of Z, do you remember what calculator function you need to use? Remember? Yeah, inv norm. Okay, so we're going to do inv norm with a 0.05. So now I'm going to go and get back to the calculator. Clear what we had. I'm going to go to second distribution, inv norm. The area is 0.05. And mu is 0 and sigma is 1 because we're talking about Z, and Z is standard. That's mean 0, standard deviation 1. Paste, enter. And you get negative 1.645, basically. That's how most people write it. Okay, so now I can go back. And we could say Z I guess I could just use this one, equals 1.645. The negative is not important because you're squaring it anyway. So now we just plug in. See if you can plug this into your calculator. Tell me what you get. I don't think I have to share the calculator. I think you should be able to tell me because this is just basic. It's not even hard statistics. So again, N is, Z is 1.645. Sigma is 14. And then E is 0.8. Don't forget to square it. And tell me what you get. So you need a calculator for this. You don't want to do this in your head or even on paper. Yeah. Now, does that mean we need to look at 828.7 accounts? Definitely not. Always round up. This is one of the cases where don't use the rules of rounding. You round up always, because that's the no more than means round up, because a bigger sample size gives you smaller margin of error. So the answer is 829. Or we can say monitor 829 spam emails. Just a note, the way you usually get the standard deviation, because that's like, how would you know that? Usually you monitor maybe 20 or maybe 30 of them or 40 of them first, see what the standard deviation is, and use that as your guess for the standard deviation. So you do a little preliminary study, get the idea of the standard deviation, and use that in the calculation in the real world. On a test, I'll give it to you. You're just going to have to know the formula and show all your work like this. Okay, so let me give you the secret word, because that was what I had to say today. The secret word of the day is margin, because you want to find the margin of error. So that's the secret word of the day, is margin. Okay, so I want to remind you again, don't forget to work on getting where your midterm is. Don't wait till the last minute. It'll go really bad for you. And send me an email where you want me to send, where you want it sent. Make sure you get project partners. And you can start thinking about your project now, something you're interested in finding out about. A difference between, has to be quantitative, by the way. So as always, I will, I'm unmuting you, by the way, because this is a time for you to really ask questions. So I'll be here until you have no questions left. Or if you have questions, I'll be happy to answer questions. This is a good time. Is this going to be on the midterm? Absolutely. Midterm not for a while. We're only October 24th right now. Midterm's November 8th. So this is definitely on the midterm. We have a lot more to do before the midterm. Will it be this exact problem? No. But will you see confidence intervals? Absolutely. That'll be a big part of it, because you haven't been tested on it yet. And you had the online midterm to test you on earlier stuff. So this is going to be a little more on the midterm than the rest. Okay. Any other questions?
I have a question just on the last, going back to the last one. I don't understand on the inverse norm function why you entered 0 and 1.
The key on that one is Z. So Z stands for the standard normal. And standard normal always means 0 and 1. Otherwise, you use X, if you remember. So for general normal, you use the letter X. For standard normal, we use the letter U. Does that make total sense?
I think so.
So it's just always 0 and 1 for this calculation, because it's part of the formula.
Okay.
So it makes it easy. And it's the defaults in the calculator. For the older calculators, you actually don't even have to enter it. It just does it for you. You just do imp norm of 0.05, and that's it. Any other questions? That's a good question. Mystery solved. So Josh or Jacob?
I think I'm good, thank you.
Okay. I'll be doing it again tomorrow, but it's the same thing. You don't need to go twice. Same examples.
Hey, Larry, what's the difference between the Z and the T again?
Okay, so the T is used because you don't know the population standard deviation. So when you don't know the population standard deviation, which is most of the time, by the way, just let you know that.
Okay.
So expect that. Then it's T because it gives you it's a little extra error because you're using the sample standard deviation as an estimate.
Okay.
So the t has a little extra error built into it. You're not responsible for understanding the math at all. It's very hard.
Okay.
But you are responsible to know that you use the t because we don't know the population standard deviation. And if I remember right, for the quantitative studies, I don't think I ever asked you one where you know the population standard deviation. So
Yeah.
I did this just for instruction purposes because you know normal distributions. And I didn't want to confuse you with a new distribution at the very beginning.
Okay. And you only use that one prompt ZINT when you have like a list of numbers and the percent?
No, the one prop ZINT was for the yes/no question.
Yes, no. Okay.
Yeah. So the list of numbers, that had to do when you asked whether you want data or stats. So if you have a list of numbers, that's data.
Okay.
If you have the mean and standard deviation given in the problem, that's stats.
List data.
Okay, that makes sense.
So thanks, Aubrey. Yeah, I forgot because your name's not written. It just says Jacob. So sorry
Yeah.
about that. Didn't mean to just, not mention your name every time I talked.
That's okay. Okay.
But that's good that you're able to get together.
Yeah. Okay, great.
All right, thank you.
Okay. Yeah, thank you also.
Good night.
You too. Have a good night.
Bye.
And for all those who are watching this as an archive video on YouTube, please post on the forums if you have any questions. And don't forget to email me when and where you're going to be taking the midterm and the contact information so that I can send it out to them. So have a wonderful night.